Hey, what's going on? Eric Cortina here. So welcome back to Believe the Target. Special guest today, as always, John Baker from TacomHQ. You guys have seen Destructor barrels, I'm sure. If you haven't, you're going to learn all about them today. You're going to learn about the Charlie. Chase Stroud, last time he was here, he had his Charlie with him. So we're going to talk about that, the Charlie, the Bravo, and the Alpha. And a lot of really cool stuff that John does with his company. So John, welcome to the show.
Thank you, Eric. It's a great day, and it's been a great day so far. Great weather, a little windy, but it turned out to be almost a blessing.
Yeah,
the wind.
So we were out at the range shooting some of what John brought with him today, and it was quite interesting, quite windy. So I believe it was a great test for what you had with you.
Actually, I thought it was too. It allowed us to shoot a variety of platforms under some condition and see how the bullet acts across wind, what it's doing on the target, and what corrections had to be made and how fast they could be made. So it was almost a perfect day. Though when we first got up, it started drizzling. I'm thinking, this ain't a good day. But luckily, the drizzle went away and the wind just stayed. And just for everybody to know, Eric, he was out there and I'm filling my Kestrel and he says, he walks out, he looks in the wind and goes, 11 to 14. Gets out the Kestrel. Okay, it's 13. Okay, I don't need a Kestrel when I had this guy around.
It was a lucky guess.
It was a lucky guess. I don't think so.
So, John, you do Destructor barrels and
yes,
of course the Charlies and all that. Why?
Well, the structured barrel actually came into my thought process in 2003 because at that point I just really started rifle shooting. And I quickly got into, well, it didn't take very many rounds at 1,000 yards that I couldn't hit a target. And the gun I had, though a very good rifle, it was a TRG 42, was excellent on initial shots, but would quickly start wandering in 9th, 10th shot. And you recognize there's heat. It would start just cooking, right? And therefore, if I shot competitively, I'd actually wait to my last moment of a shot, trying to get as much cooling in place as possible. And so when I first thought of the idea, part of it was from my background vibration, which has to do with some heat, how to dissipate it, how to direct it. But at the time, I couldn't pursue it because the technology wasn't there. I couldn't make it. Mm-hmm. So I had to wait for technology to actually catch up where I could produce the first pieces. And the first barrels we made, we threw away about 8 of them. And every time you're doing that, you're about crying because you're making mistakes as you're learning what the extremes are, what failure points are.
Well, look at SpaceX. They throw away full rockets. I mean,
you got a point there.
Barrels
I feel better
cheap.
now. I feel better. And but the heat was a part of the component, but also my background in vibration told me that things were happening within the barrel that I could potentially correct, or how about this, direct. What I could quickly recognize from my past is that you don't get rid of the force. It's there, but I got to tell it what to do. I can't just let it do whatever. It's kind of like taking a round and saying, I'm going to blow it up my hand. Well, which way is it going to go? I don't know. Well, then I shove it down to a tube. Well, now it goes somewhere. Well, the vibrations are the same thing. They are being produced and they are going somewhere. My goal is to make them go the way I want to, and along the way, potentially reuse them at source. But once I get them moving in all the same direction, that starts affecting the barrel and how it moves in total, not only how the bullet, but how it moves on the shooter. That the recoil does not change. Force is force. But if I can take that force and direct it so it's not doing this on me, that's a straight back movement, well, now me as the shooter, the barrel now becomes part of the system that allows the shooter to go faster follow-up, more consistent follow-up. How about something that people don't think about is, what's my action on the scope? If the whole system's not moving, well, my scope isn't moving as much. Well, if I'm not moving as much across the system, my zeros stay better. So it was a piece to say, okay, how can we solve this? And actually, my initial test was actually when I was still doing vibration. And the tools I made did not look like anything that had been made for the last 30 years. But I quickly recognized their efficiency. was way higher, the amount of energy I needed to drive into it. And you recognize that, you go, okay, I can apply this to a barrel. Now, what can I do with it? So that's kind of how it started, a necessity of failure.
Yeah. So you talk about vibrations. I mean, we kind of essentially do the same thing with the tuner.
You are doing exactly the same thing.
Except we don't redirect. Well, I guess we do.
You actually do.
Yeah, we do. We're trying to, the best way I can explain is just find a happy place, and which is going to be different for every barrel, and find a happy place, and then just let people have fun, enjoy it.
Yes.
Are you trying to eliminate vibrations, or what are you essentially trying to do?
My goal is to direct it. So if I look at something that everybody knows, electricity, where does the voltage run? Does it run through the center of the wire or run the outside? It runs down the outside. Fiber optics. I have a light wave progress, but where is it on? It's critical angle moving along the outside, not the center, because that fiber optic, even though it's clear, the light doesn't leave it. I'm making a bend. It doesn't just go out the side. It follows that curve. So my goal is to have that vibration follow a path. I'm going to give you a direction to go, and you're going to stay on it. Hose, water in the hose, until it hits the sprinkler head. So once we set up the movement of that barrel, and we're starting at a source, you're correcting an end. You're correcting a failure that's existing. And as we already know, our barrel isn't for everybody. Your tuner is for everybody because it can fix that movement down the end. And so part of the goal is that, can we release the bullet in the same location, how it affects the bullet as it leaves the barrel, and so on. So we're looking for a highly consistent release. If we're going to fix it 100%, it might become nearly impossible, without some other outside tweak, because you can't fix the metallurgy. Even like the tools we did, if I vibrated this tool, and let's say this tool was 6 inches in diameter, 4.5 inches thick, a D2, and it was Rockwell 52, so it's a pretty stout piece. You could remove thousands and change its frequency. And what people don't also realize is that if I have a tube or a shape and I send a wave into it, it doesn't just pass through like a flat plate to the other end. It gets distorted. It can get split, go different directions, become more than one wavefront. But at the very least, I guarantee it's going to get up and curve to some degree. Well, if that whole thing's now moving, because if it moves some distance, some wave number, and the outside isn't following, well, at some point it's also retracting against that same wave. Well, now what do you have? You have a fight. And now what's the barrel doing? It's fighting upon itself. And those movements change with heat. As you apply heat, that movement rapidly changes position. And at times, astoundingly so. So if we were to run these tools and we just let it go stupid and didn't pay attention to it, you could actually take that D2 with 110 volts of energy applied to it and break it in half. Just shatter it. Because the vibration you put into it was going, I don't like this. Kind of like the opera singer in the glass.
Right.
Singing away. It's happy for a while, but you put it in the wrong place. And that's the barrel. It's a piece of metal that's wanting to go, I want to do certain things, but I don't want to do other things. In fact, I'm going to fight you in every way there is. So our goal is to tell it what to do within the frequency that round explosion event takes place and what it's doing down there as it moves down the barrel. The other thing too is that, a common thought process is, well, how can you improve upon a tube? And that's a fair question. But that's like saying every airplane, why does it have a wing spar? Why aren't they just round tubes? Because at some point I can take strength and I can reform that material and put it into a strength condition. I-beam.
Right.
The I-beam in a given direction, weight for weight, stronger than a round tube or round rod. So what we've done is, by doing that, we've made the barrel much more resistant to not only bending, but also twist. As you figure when a bullet goes bang, I have an ignition wave because it's going bang. Then I have a wave front hits when that bullet comes forward and goes, I'm hitting the land. Let's take a hammer and hit a nail. The next thing in place is I'm trying to twist the barrel because that I have an object that wants to stay stationary that I'm now trying to spin faster and faster as it accelerates down the barrel. Well, the barrel's now wanting to do this. So I have 3 events of energy taking place that that we want to get control of. Kind of bouncing around there.
Yeah, no, that makes sense. So there's a lot happening.
There's a lot happening.
So how do you go about figuring this stuff out? You know, you say you have a background in vibration.
Yes.
Can you talk about what that was?
Well, what we did was what you call ultrasonic machining. And people are maybe familiar with ultrasonic welding. If you have a toothbrush, at home, it's been put together in an ultrasonic welder. The head comes down, touches two pieces of plastic, and it melts them together. And in those cases, what you do is you literally are making a version of a gun barrel. You have a drive, electronic drive, and it drops into an adapter or a booster. And here's one of the things that people, when the argument about how vibration works, it'll run into the booster, then it runs into your tool. So that booster and the tool are essentially the barrel. And by what we're doing then is we're designing that tool so it will vibrate within the system correctly. And depending on the size of the tool, depending on your focus that you're trying to, that changes that shape. And some of the shapes that you pop up with, you can't put in your mind and go, why does it do what it does? But the vibration's certainly happy. It will do something different. So it could be everything from wasting it. It could be making a curve into it. It could be, making it short, making it taller. Will all change how that tip moves through the whole system, and can it run cool into process. But in welding, you're talking about events that last 0.3 seconds versus we had to last 30 minutes. So the efficiency of the tool has to become its orders of magnitude greater of control than standard welder. So therefore, how do we have that tool sit there and vibrate under those conditions for 30 minutes, not overheat? And people have no one, just an engine, there's a difference between 10 seconds to run and 10 minutes to run or an hour. What do I do with the heat? Heat is a byproduct that usually you don't want to deal with. It's a headache. So in our case, we're wanting to control that tip and what it is doing. So therefore, as you had failures, you redesign, you rebuild, and you eventually look at how do I measure these movements of and what's taking place. And so back to, if you can't measure it, you really don't know what's happening.
Right.
So we got down to measurements where we could actually measure the wavefront across our tools, amplitudes, direct real time, what that displacements look like. And you could redesign the tool until you took that hump or whatever it was and made it flatter and flatter and flatter, and what it was doing on the very outside skirts. If you looked at our barrel, you saw a lot of features on the outside. They are meant to deal with the movement of that wave and also even what it's doing on the outside edges of it and how it impacts the center of the barrel. So that system acting as a barrel, we want to move 3 thousandths in total movement 20,000 times a second. And efficiency becomes important. So when I look at the barrel, it's literally that big tuning fork. It's part of the. So
the big question is, you talk about vibrations and such. The big question is, does the barrel vibrate before the bullet leaves or after? Okay, right? So does it affect? Because that's the big question.
It is, and honestly, I know where I stand on that, because to say it doesn't, it'd be like throwing away all my experience in vibration, throws away what you know about sonic welding. There's whole computer models that describe vibration, and
what. And I don't need computer models.
Right.
I'm going to tell you my experience. Just listen. I'm as dumb as the next guy.
You are not.
All I know is, the way my head works, if there was zero vibrations in the barrel, as I increase powder charge, I would have a perfectly
vertical
event. However, it doesn't happen. As I increase powder charge, the group will move right, left, down, whatever, in all kinds of different directions. Right.
Yep.
Why not, exactly. And why are they not all the exact same size, just faster? So in my opinion, based on looking at the target, I'm like, it's got to be moving, because how come now it's going that way or this way?
Right.
Or sometimes they
So
flip-flop.
to your point, and I go through that argument that if somehow I exclude the barrel, that it had nothing to do with anything, the bullet just leaves, then what's the latent force that exists afterward that says, well, now I'm going to go ahead and have you do this and go somewhere else. Also, the latent force is if the force is gone and the bullet is now left the barrel, then why does the gun get up and vibrate and move? What you shot today, I think we could agree with that our movement upon the gun is very different than what you would expect under normal. And it's because the barrel isn't moving to the same values, the same numbers.
Right.
So there's no doubt in my mind. And have we had some events where we've made improvements on how the barrel acted? Absolutely. Absolutely. But I also know this. Across the board, again and again and again, we've shown that we can shoot a wide range of round bullet weight. And ladder testing is almost irrelevant other than velocity. It doesn't fix that. But it's such a high range that you go, well, if it's not the barrel, then why does it exist here? But I can't do it here. There's a separation of.
I mean, all factory ammunition would shoot amazing in every rifle if
yes,
the vibration. You know what I'm
if
saying?
it didn't matter,
It wouldn't
it
matter.
didn't matter.
You could never improve on factory ammunition.
Right.
If vibration, again, I may be wrong, but this is the way I see it. How come if the barrel doesn't vibrate, nothing happens? Why is it that not all factory ammunition shoots in all rifles? And why is it that I can make it better with hand loads? You shouldn't be able to.
You shouldn't be able to.
But you are.
You're tuning the power source in my world. You're tuning the power source. If my power source is not clean in my past world, well, the tool wouldn't work. It doesn't vibrate. It'll vibrate, just not the way you want it to, right? It will fail. Either not do the work, fail, or whatever.
Right.
And in our, it's one of those things that in the world I came from, if I had that tool and I had literally a couple thousand hypodermic needles on the end, right? And these needles, when they went into movement, were actually that grams of needle weighed 90 pounds each. There was that much G-force in place. But if there was anything wrong with that build, instead of the needle going like this, you would see it orbit. You could see it visually. And if I measured across the pattern, I could tell you where the horn was bad by just measuring the diameter of the hole, because the pin got bigger. It acted bigger. It can never make a small hole. It always make it bigger. And when I see that, I go, there's my barrel. It's orbiting, it's moving in some motion, which takes my end result, my case pins, 2,000 at a time, and makes them go do something else. So you are tuning that initial energy event to be consistent to the material it's in. You're not fighting it. You're like, no, let's fix this. Let's fix this. Let's fix it. And it goes, oh, I like that, and gets up and moves. Versus, it's complete out of phase. It's erratic. Is it consistent, or is there pre-ignition events taking place, small spots and so on? What's that doing with the barrel? Let alone how the bullet is acting. So your tuning, in my mind, is fixing the energy source. It goes, I like this. Car guy, your car out there. You put the wrong gas in, what's it do?
Not much.
Right. And in your case, hopefully the car's smart enough to go, I'm not going to run, and just shut itself off. Right. Or in the worst case scenario, it goes in pre-ignition and just puts a few holes in your pistons. Well, what's the difference?
Yeah.
It was just the energy source.
Yeah. I mean, yeah, I get it. It's and again, so you and I believe the same thing, that the barrel vibrates, and that therefore we must tame the vibration.
Tame the vibration.
We just have different ways of doing it.
Absolutely.
I have barrel tuners. You actually machine the barrel to, as you say, channel or control the vibration in certain ways.
Yes.
So we're there. Okay. Now, what are the benefits?
The benefits, along with what's my target doing, because in the end, that's all that matters.
Right.
We
leave the target.
In the end, it doesn't. In the end, what it does at the target level is the end all. Everything else before that, you can, if we call it furniture, right?
Yeah. Well, that's how we get graded, right?
That's exactly
the
right.
shooting, when I guess that's how you get graded. If you're hunting,
Yep.
the difference between a hit and a miss.
It's
right?
a difference between a hit and miss.
If you're a competition shooter, same thing.
10 ring, 9 ring.
If you're in combat, right?
You betcha.
Life or death, you know. So there's that's how we get graded, the
Yes.
target.
So what I'm looking for when we put this in is not only that it will shoot a wider range consistently and predictably. In other words, I'm a guy in the field and I have a crate of ammo dropped on. I can't go out and zero and play with it and get all this and that. Within reason, I'm hoping what I have will shoot that well. So the first thing is, how consistent can I be across a wide range? Is it a diva, or is it the farm girl who's going to go out and, you know, feed the cows, you know, and so on? Then the next point is,
now I'm going to have to build a rifle and call it the farm girl.
That's right. And but then the next piece is coming to line is one of the things I could see on the older rifles was how fast my velocity could start changing as my round count raised. My SDs start drifting. My ESs start drifting. Well, how do I have a long string? And I know people say, oh, but you know, it's not going to happen in 3 shots, not going to happen in 5. And you're right. To that person, it might not matter. At some point, though, a top-notch competitor is going to care about, does my SD stay flatter? If it stays flat at 20, then I know it's flat at 10. I'm never on the edge of failure. So
Right.
can I keep my SD flatter? How about heat? Well, heat's bore SD. The other thing is Mirage. I'm a competitive shooter. If I don't have, or military, if I don't have Mirage coming off my barrel, am I engaging the target more predictably? Yes. Okay. The cooling event. If the barrel can run 20 or 30 rounds plus and pretty well be within 10 to 20 degrees of ambient, back to that, what's my predictability? What can I expect for shot strength? I think people forget that if I shoot 3 rounds, 5 rounds, and I go, it's good. Okay, it's good. But you never test 10 or 12. You never test to where does failure start taking place. Then you cannot be confident that when you are competing or engaging, whatever, that you are not, don't purely drop in the edge. That all of a sudden there's a failure, a missed target, and you go, why? Well, because you are not well within an SD or, well within the bell curve of your distribution of your performance. And therefore, we want that number a long ways out there. That, in other words, if someone says, we'll test 10 rounds. Okay, I'll test 30. You want to do 30? I'll do 50. You want to do 50? I'll do 70.
Right.
Because we want that bell curve so wide for that predictability that no matter what the shooting is, you know that it's going to fail out here, but you're way down here. You're nowhere close to that value. Your CNCs. You more likely have tool lives sitting up on there. Well, you don't wait for the tool to break off in the part you're making. You're going to change it before it wears out because you ran enough parts to go, it's going to fail at 250 parts. So therefore, I'm going to change at 170 because I never want to be at 250 and have it go break. I'm just going to take it, throw it out. It might be running, but this is what I know. My next part's still going to be good.
Right.
I'll never hit that failure.
Well, that's how I do barrel cleaning.
Mm-hmm.
I don't ever wait for it to fail.
Yeah.
Or groups open up. It's to me that's too late. It's too late.
Right.
Changing oil. You don't change the oil when the lifters start knocking.
No, not usually.
It's a bit late by then, right?
Yeah.
So no, I get it. Now, you're talking about, earlier I talked about how not all factory ammo shoots the same, not all, but sounds to me like what you're doing with your barrels, that's essentially what you're getting. You're getting a more predictable, more farmer girl,
yes,
lenient, more. It'll just you can feed it multiple different types of ammo, and it's going to be
predictably consistent.
Yeah, it'll be better.
Yes.
It'll shoot the most amount of different ammo good as if you had just a conventional barrel.
Yes. And we've done that more than one time. We've been, we have top shooters come along. They'll say, well, why don't you show me a ladder test? Let's say we're shooting our Norma, our 300 Norma. Mm-hmm. And okay, let's say our typical round is 82 grains. And okay, what am I going to show you for a ladder test? 76, 77, and 84 up to pre-ignition and peak. And I'm going to tell you what, it's not going to show up on a 100-yard target. It's going to shoot the same little group. It's not going to show. We're going to have to go to shoot 400 to 500 and shoot enough groups to say there's a difference, because it will shoot that ladder test within reason about the same. So what we do is we show up with 168s and 230s, 168s, 190s, and 230s. And we'll shoot the 168s at 3,400 feet a second and 2,200 feet a second, being extreme spread. And we'll shoot the 190s and all the way to 230s. Okay, so we'll have that 60 grain weight change on the bullet. And essentially, we expect little clover leaves or groups to appear, essentially, back to that point, vertical. If the barrel is not moving, and it has nothing to do, then I would expect vertical events to take place. But that's what we see. We see verticals occur as we shoot that change in round. And back to your point, someone might say, well, I'll never do that in the field. You're right. I'm just on a $20,000 hunt, $50,000 hunt. I have a ride in my airplane. My ammo didn't get here. Now what? I got to go to the store and buy some. Well, as long as I know this, as long as I go to the store and I buy a decent ammo, chances are the barrel's going to pick up and shoot it.
I guarantee you the first thing they're going to look for is the same ammo they were shooting. They
you bet.
Lost.
You bet.
Because that's what they tested with.
Oh, you
right?
bet.
So you're saying, obviously, look for that first.
Oh, yeah.
But if you can't find that, anything comparable should do just fine.
What we found overall within reason, the barrel can't fix concentricity. Will 2,000 out of concentric show up versus 4 versus 6? You bet. It starts opening the group up. It'll be a nice round group. It won't go out somewhere, just, But do I expect that if I pull a velocity off and I have the BC of that bullet, can I make it pretty darn predictable? More than likely, yes. Because the barrel is being stable and how it sends that round downrange.
All right. You just said the group's not going to be small. It'll be big, but it'll be consistent.
Yes.
So no flyers?
Essentially, flyers really start dropping out. And we have a West Coast bench wrestler, and he is ranked. And he shot our barrel in a light gun. Now, the first thing it says, this gun's 4 pounds underweight because your barrel's too light. Oh, you're right. You asked us to fit a channel. We took metal out of the barrel, and it's lighter. But what he said, and he pointed out, he says, John, I'm not going to talk to you about an event or one win or whatever. I'm going to care. All I care about is end of the year what my aggregate score is. All I care about that is that final number. How did it do? Now it just happens the barrel, that gun went on one of those scores where it was one of the few barrels to shoot some group size at 1,000 yards. Okay. Oh, there's only 12 other guns that had done it to date. It just happens that one that did it also.
Right.
But he said at the end of the year, he said, you know something? I can't say it's more accurate than my standard barrel. And you want to know something? Never said it was. Are we going to outshoot you, Eric? No. I don't think it's possible. One hole is one hole. Peak is peak. But what he said was, what was missing, though, was my flyers. He says, as the seasons go by, every once in a while you put a round down and you go, where'd that come from? He says, I didn't see him. He said, that alone almost makes what you have worthwhile, because that variable drops out. That if I can get rid of, then what's it worth to me as a competitor? Well, guys who shoot 1,000 yards, they're probably chasing every little piece they can, and what that means down there. So if I shoot out of concentric round, am I expecting to go left or right? No. But it'll just make a larger group because it's out of concentricity. If I look at it, if I have factory rounds, I put them across my concentricity gauge. First thing, I just pull up the ones that are really bad. I tweak a couple, and then I go shoot. Because I know it's going to now shoot. That's what I know. I just got to change. I'll chase my velocity or change my BC, because it's not going to fix velocity either. Speed is speed. And that's another part of it. But what you're doing that is you're removing variables of movement on the target down to I can focus on one thing. What's my velocity content? What can I make for consistency?
So I'm going to be honest with you. A lot of what you're saying,
a
lot of what you're saying sounds like BS.
Oh, I bet.
But before we did this morning, we went out and we shot.
We did.
And we shot. Probably the most interesting test that we did was that 190s.
Yeah. Or 230s.
230s versus 168 grain bullets.
Yep.
Now, you told me that test you usually do it 100 yards.
Yep.
And I said, well, we're doing it at 500.
Yeah. You made me poop my pants for a second.
We said, no, we're doing it at 500 yards. It was extremely windy, like we talked about. Still windy now. And the result surprised me. And you seem surprised too, because you've never done it at 500.
Actually, it was a hope. I told you before that the test is so extreme that no matter what, you got a little butt pucker going in when you have someone sit down and shoot, because it's on the line. Because at that point, you pull the trigger. What am I going to do? Make excuses now?
Yeah.
I can't.
So for those of you that are watching this, and you will see that on my regular channel, we took 5 of each.
Yep.
And I had Clay shoot it. He was shooting blind. We're shooting an electronic target. And I was handing him the ammo. You only had 5 of the 168s.
I didn't think I was going to shoot 500 yards, right?
Yeah, versus you had tons of the other stuff. So before, in preparation for the test, I told Clay, well, you know what? I don't know how much higher the other ones are going to hit. So let's set the scope so that we hit low on the target on the first with a heavy bullets,
the 230s.
With the 230s. Which means, the only thing the other ones will do is hit higher. It's 500 yards, right? Because they're going much faster, about close to 200 feet per second faster. So we did that. We set it up that way. And the very first one that I handed Clay was the 168. And it hit down at the bottom where we had set up the 230s to hit. Mm-hmm. At which point I looked at you to go, hey, which are the light ones? Because I think I just handed them the heavy ones. And you said, those in your hand are the light ones. And I go, wait a minute, why are they hitting way down there? So I told Clay, go ahead and click up a mill. Because now I realize they're actually going to hit very close to each other. And then we shot alternating heavy, light. And I was handing them to Clay. Clay was literally I was actually throwing them in the chamber. In the feed ramp, Clay was closing the bolt, holding center, squeezing the trigger. That's all he did for 10 shots. Long story short, we shot technically 4 and 4 because we had already wasted one. It put 8 or 9 shots. I forget if we counted the other one or not. The point is, 5 inches at 500 yards, 8 shots, 4 230s, 4 168s, going about 150 to 200 feet per second difference. We had a chronograph measuring this stuff. And at the target, same thing. The speeds were 150 to 200 feet per second difference on target. However, they all went into the same group of one MOA.
No left or right.
No left or right. I mean, just a nice group. And by then, it was like 15-mile-an-hour winds. So I was very skeptical until we did that test, because we've been shooting other stuff. Mm-hmm. That test to me told me there's something going on in here, because they should not go together.
They shouldn't go together. Plus,
especially the curveball that I threw at you is because you said this test is to be done at 100, and I said no,
because I didn't know how the bullets would fly after that. I didn't know what they'd look like.
Well, and I didn't know if it was, to be honest with you, I didn't know if it was a kind of a magic trick type of thing. You know what I'm saying?
Yeah, and that's
you have to understand.
Oh, absolutely.
I'm skeptic. I'm skeptical, and I said, you know what? No. We're doing this at 500 yards, and we should see just direct vertical. Not only did we see that, ballistically, it may have just been where they matched up.
Yep.
The point is, they were on the same group.
Yep. And the 168s were having an 80 thousandths jump, because I couldn't load them out to lands.
Yeah.
The 230s have a 25 thousandths jump. These had 80, because I would stick them in far enough that I could hold it, measure it, make sure it was good. So, and we've done the test before on jumps. We did a 33XC where we went from touching lands to 200 thousandths of jump, and a 1,000-yard target the vertical didn't move. So even on that jump, do I think you can move your group? But it wasn't a gigantic significant.
Right.
The group went somewhere.
Yeah. So anyway, when we did that test, that's when I knew. Now, we're shooting at 300. I did shoot it as well. After Clay shot it, I said, all right, I got to shoot. Because another thing happened. This is what kind of factory ammo was it?
It was Norma 3 230 hybrid.
Is this the burger hybrid?
Yes, it would be a burger
230
hybrid.
grain burger. Clay, well, I told him, I said, well, go ahead and shoot this rifle and let's get it sighted in, at the bottom of the target. I said, just go ahead and shoot. He shot 2 shots and they went into like 0.56 inches at 500, the 2. And again, he's shooting blind.
Yep.
And I said, hey, go ahead and shoot 3 more. And he said, well, I just had 2. So he asked you for more ammo. You had to go get the ammo. You gave it to him. And I said, hey, just hold the same place. Keep in mind, about 15 mile an hour winds, anywhere from 12 to like 17 gusting pretty hard. You went to the truck. You got him 3 more rounds. You gave them to him. He shot the next 3. The next 3 shot 1.5 inches. The overall group was
2.18.
2 point something. And 1 and 2 were here, and 3, 4, and 5 were just like this. And you can tell it was just a difference in wind. The wind has switched or changed by then. It kind of let off a little bit. Mm-hmm. But still, the group was only 2 inch and change at 500 yards. Sub half MOA. With factory ammunition, 300 Norma in very high winds. Yep. I was impressed. I was very impressed.
Well, one of the reasons that I wanted to come here is I look for the credibility to be applied by top shooters like yourself. It doesn't matter what I think. I'm not a skilled shooter. Can I shoot? And do I expect some performance? Yes. When I test my stuff, if it's not shooting clover leaf, I'm not having a good day. But can I do what you do? No. If I shot the tens of thousands of rounds that you guys shoot? No. So having your appraisal to look at something like this becomes very real. It isn't just I wish, I think, I may, you have a whole background, significant background. You go, this is different. Well, yeah. Also, that means something.
It was different even in the recoil. Now, explain to me why the recoil is different than a conventional rifle, because it just felt different.
And that's a common statement for people who get behind our barrels.
Different in a good way.
Different in a good way. And it's everything from the guys who shoot the 460s all the way down to 22s. The recoil is different, more manageable. Now, and we had a recent top guy, or consider a blogger, shoot our stuff, and he says, I think the recoil is about the same. But later on, he said, but to stay on target really well. There's the point. So we didn't change the energy. The same. Right. We didn't change the energy, but how it's being put into the system. Part of that goal is that, especially as a service guy, if I'm engaging somebody, how fast I can do a secondary follow-up is really, really important. So our goal by directing the energy within the barrel to move in one direction, that means the whole gun is moving in one direction. I'm not letting it get up and do this. I think people think that somehow whip and system ends at the chamber. Well, it doesn't. It's at the case. It's in the action. It's in the chassis. It's in your cheek. It's on your shoulder. And the gun's just moved on your shoulder. It's moved on your cheek. Well, now you got to realign yourself and the whole system. That's all time. Versus I want the gun to come straight back, push you, and settle right back down on the target as fast as possible. But yes, that's one of the primary design goals of that system, is to make the whole system quiet. And we use the quiet. It's not bang quiet. It's the quiet is how you perceive target impulse.
Yes, so as in movement. I mean,
movement.
Clay and I both shot it. And then we shot your AR-10 that you had, the 6.5 Creed.
Yes.
And we also ran another test where you said, listen, just get on target and shoot 10 shots as fast as you can. And I don't know how fast I was going. I'm sure I was no Jerry
You're
Mitchell.
shooting a sub-second per round, pretty quick, I think, yeah.
And I mean, the reticle was just, I mean, it was right there.
It stays right
You know,
there.
the first few shots,
You're tentative thinking about it.
yeah, thinking about it. And then after a while, I'm like, oh, just pull the trigger.
Pull the trigger.
Just pull the trigger.
Yes.
Just don't worry about aiming anymore. Just, you know, manage the recoil
Yep.
and squeeze the trigger. And it was right there.
Yes, it was.
It was pretty impressive. Clay did the same thing. We both ran the test. So 6.5 Creed, AR-10. We got it. We verified that we would be on target because it's super windy. And then we ran the test. He ran 10 shots. Then I ran 10 shots.
Yep.
And I immediately said, shoot that barrel.
Yep.
I want to know the temp. Because we had just ran 25 or so shots through this thing, rapid fire.
Yep.
That was the next thing.
Yep.
Ambient was, if I remember correctly,
69 degrees.
69 degrees, and the barrel was 80, 82.
Yep.
It was like 13-degree delta from
Ambient ground temperature.
and the chamber was cooler. The chamber was ambient.
Yep.
And the middle of the barrel, kind of where I shot it or you were shooting it with the
Right.
thermometer gun, it was only like 12 degrees different.
Yep.
Explain that.
Well, in this case, physics is working for us. Heat wants to move somewhere. So the radiator is the heat sink. So heat's moving toward the heat sink. So though there's heat from the initial powder event, which in most cases is the heat, the metal's going, nope, I'm going to be cold. I'm going to move it. It's you know, the extreme, hate to be a car guy again, but you're out working your car. One day it's freaking cold. Grab a wrench. See how fast, especially in ultra cold weather like zero, how fast you get frostbite off that metal because your heat is moving. It's moving you. Inversely, hot day. What's that wrench like? Jesus Christ, you know, you scald yourself.
Right. Even though it's the same.
Yes. So even though it's the same wrench. So the barrel.
Well, I got a question. Is the wrench not the same temperature as if it's 100 degrees?
It's conductivity.
That's what I mean. The wrench is, you're 100 degrees, the wrench is 100 degrees. Well, when you touch it,
the heat wants to go toward cold. It's wanting to move. It doesn't want to be hot. It's going to move toward cold. So the radiator is in front of everything. So that barrel is doing one thing. I'm wicking off that chamber. It's wanting to leave the end. It wants to get in the air. It wants to go somewhere, but not stay soaked.
For the non-car people, tile floors versus carpet, they're the same temperature.
Yep. But which one pulls heat out of or adds heat to your feet?
Right.
Fastest as you walk across.
Right. Yeah. I mean.
So even the Norma, you shot 25, 30 rounds on that, and it was almost identical. It was sitting at 80 degrees.
Yeah, it was. So that's got to lead to longer barrel life. It got to.
It has to.
Right? Because it's not it's the heat that kills. It's just like anything else, like a car. You can run the car 500,000 miles, but if you overheat it one time, it's pretty much done.
And so the metallurgy on if I look at metal, its performance isn't just a steady one of these. If you look at annealing values versus tempering values, there are different peaks, how long you hold them, and so on. But it kind of notches along as it's going through a phase change. Our goal is to never let the initial rifling get hot enough that it wants to start doing bad things, like fail. So if you can wick enough heat out that you're just below that threshold, guess what? Your life has to be higher. It will be higher. There's no way around that it won't be higher. Mm-hmm. Now, are there more than one condition that's creating barrel life? Absolutely. And are we addressing that as far as our next generation? Yes. But the first one was, how do I dissipate heat?
The reason I'm asking is that 300 Norma shot extremely well. I mean, we're shooting sub half MOA at 500 yards and high winds. And you're telling me this barrel has over 3,400 rounds through it?
And it's not the only one out there. This isn't a fluke. There's a competitor, he probably will comment when he sees your stuff. He has one. He'll tell you that this barrel shoots the same, just as well as it did when I first tuned it in, and he's at 3,400 rounds. We had an MRAD out there that Chris pulled off at 3,600 because it finally exceeded 1 MOA at 3,600 rounds. And we just took it back so we could inspect it, looking for root cause failures. And so we fully expect those values. Now, within reason, can you about torch anything? Yes.
Right.
But if I look at how the pace that people are shooting and how they're moving, well, now we potentially can design the barrel around how do I dissipate the BTU event? How do I put it somewhere else, but not in the barrel? And today when you were shooting, you shot the 300 normal, you shot the 6.5, and we put some rounds through the 6.5, and you shot the 6XC, and the barrels never really exceeded 81, 82 degrees the whole period.
Right.
But that's what we expect. That's fully what we expect off the barrel, that it will run. That's back to the flatter SD, better ES, takes place because it becomes predictable, that I can, within reason, predict my 30th round is going to act very similar to my first round because we haven't moved things that far. It's one of those, back to, to your point of what's the heat doing? What's that predictability? 3 shots, does it matter? Overwatch, how many bad guys am I shooting today? Am I starting? Can I raise my hand and say, hey, I'm at 10 rounds. I got to stop. And have I seen that? I've been on firing where people are truing their weapons and they'll stop at 8 to 10 rounds because they can no longer engage the 1,600 meter target because their group opened up too much. Mm-hmm. And you go, oh, what? How good is that? Right?
Yeah. Well, all right. Somebody wants to get one of your barrels. Tell me what the process is like, and because I have questions. Do you chamber before or after? Contour.
So the first thing is that, so everybody knows, the chambering, as long as a smith can hold whatever diameter they want, it's straightforward at that point. It's just like normal. Okay. So we work with everybody's blanks. Okay. And we've worked with high-end blanks, $700 blanks, down to $125 blanks. Okay. So we've done the whole gamut. So
is there a difference in performance with the, now that's the $1 million question. Do the premium barrels perform better than the cheaper stuff?
I'm going to be very careful how I answer this, because at first glance, short statistics, no. The metallurgy, the preparation of post events, and of course the quality of the rifling is very, very important. It's stellar. But it'd be like saying, Eric, you have a 5-axis CNC out there. Is it better than my mill, my manual mill? Well, technically, the answer could be no, because it depends on how that other manual mill was run, who ran it, what was the materials, and so on. Could it match? But at the same time, you could go, well, but how many did this guy make on the manual mill versus my CNC mill?
Right.
And all of a sudden you go, well, what's the cost difference? Well, there's a reason that 5-axis mill runs, because he makes 5, you make 100.
Right.
One of those bits. So we have recognized certain attributes in barrels that I go would be detrimental to not only its accuracy but its life. And if those features, negative features, are not present, the barrels seem to do not bad. Okay. Now, and I'm being very careful, because some of the barrel people we have, the straightness of their bores is stellar. You go, boy, there's some quality here. And can you just say that exists everywhere else? And it would take a shooter like yourself who's putting enough rounds down to go, yep. It's like someone when they challenge me and they say, our barrels are snake oil. And you go, well, how many rounds have you put down of, let's say, Krieger versus Bardline, that you statistically can say one is better than the other because you put enough rounds down, and across how many barrels? Well, you need 100,000 rounds to pull that number out, if you're lucky. And let alone negate the shooter, just completely out in the ammo and everything else. And I think to a degree we can fall into that, because the metallurgies have gotten so good. Post-treatment, it's no longer a guy walking around in a big old green coat, shoving something into an oven, doing this and coming back in a bit and, taking it out. Everything is so highly cycled and so well controlled. You can get material certs. The quality levels of the materials that are put in is so high. Then it comes down to how are they producing? What's that end piece? So complex answer, and how the price.
Give me the short answer. Are premium barrels worth the extra expense?
I'm going to have to say initially, I'm going to say yes. I'm going to assume their quality control is higher.
Okay. All right. Because, your process is not cheap.
No, my process is not cheap.
And that's what I'm wondering. It's like, do you want to apply, how much does it cost? Let's just say, give me a standard barrel.
So our process is going to add $1,000 to $1,200 pretty quick.
Okay. So let's say I'm going to spend $1,200. Mm-hmm. And obviously I'm looking for it to shoot as good as possible. Mm-hmm. Should I
would buy the premium barrel.
Okay.
I would. Because back to that, as a long-term event, that flyer error, I don't want to see the flyer error. Is there enough data that says, okay, but this lesser barrel, price-wise, is there enough data to go out there that out of every 100 barrels made, how many come back for quality problems? Versus the high-end guy, you go, how many barrels have come back for quality problems? And then you start separating who shot it. Is it the weekend guy who's going to go hunting once a year, walk out to the range, shoot his 9 rounds, go back in and go, I'm going to go shoot a deer?
Yeah.
Or is the guy who's going to shoot 1,000 rounds a week?
Right.
That's two different answers, 100%.
Right.
But when we look at what we're doing to that point of we're about to add $1,200, which one do I want to have a potential flyer on?
Well, so back to it's not going to make a bad barrel better. It's simply going to...
A bad barrel cannot be made better.
Right.
It might group a little better, maybe, be a little more consistent, but the rifling is not right. If it's got grooves in the rifle, if it's got pits, if the rifling isn't consistent, if they haven't finished it, you get in there and someone's drilled and they claim they lapped it and you go, I can still see drill marks.
Yeah.
Well, or if the post heat treating isn't correct, soft materials or stressed materials, well, it don't matter what you're doing. At some point, don't matter what you're doing.
So, all right, let's just say someone, let's say like me, wanted to get one of your barrels. Okay. What's that process like? So I have a barrel blank, right? But they typically have to be larger.
Typically, now this is one of the things we have learned, and because we measure everything we drill, is the larger blanks all make straighter holes on average. End of story. Doesn't matter what it is. Okay. So we choose that larger blank to have a more consistent hole that we'll do our process on. And if our process is straighter, I can pretty well guarantee the original hole is probably straighter too.
How much weight does it typically remove?
We will typically quickly remove 30% of the weight, 40% of the weight of the blank.
Okay.
So that's one of the complaints we have is that people will order something, they'll order it to fit their barrel channel. Then they'll come back and say, can you make it heavier? Well, you told me to make it fit your barrel channel.
Yeah.
I'm going to make the same diameter and take a bunch of material out. What do you think was going to happen? One of those
Add
bits.
concrete. So that's what I'm asking, right? So that's why I'm asking these questions. For example, if I have a barrel that weighs 12 pounds, right, and I want to maintain the weight, let's say 10 pounds for ease of math.
You'd have to make a bigger channel.
Well,
literally,
what I'm getting at is this, right? If I have a barrel that's 10 pounds for my rifle, and my rifle is set up that way, and I want a 10-pound rifle, and you said about 30 to 40%. So I need to look at a barrel that's 13 or 14 pounds.
Almost, yeah. And we can actually tell you to the ounce what your barrel will weigh.
Well,
including down to, if you give me the chamber, we'll take the chamber out of that weight also. So we can get very, very precise on the weight. And for instance, one of the things that people it's not readily apparent. I showed you a 1 1/4 inch barrel out there, the 300 Win Mag. That 1.5 inch barrel on the 300 Norma only weighs like 1.5 pounds more. Because as the diameter is going up, my cores that I'm taking out are getting larger proportionally.
Okay.
Faster. So therefore, the core area is now greater per size than the small one is. Okay, because we had a limit on how small, what's my separation, and so on. So actually, the larger barrel per weight is weighing less, or per size cubic area, than what the smaller barrel does. So like in the Norma, that's a 32-inch barrel. That barrel weighs 7 pounds, 7.5 pounds.
So get your barrel blank.
Yep.
How long does it take for you to do the machining?
It takes us typically 4 months to 6 months to get everything through. Now, part of that is we cryo basically everything. And the reason being is experience. I know there's people out there who will say cryo doesn't do anything on a barrel. Well, I would argue that. Part of my past. We went through cryo testing very specifically to see how it would act on materials. And let's take something simple. And we'll get back to my example. Automotive. Every oil pump out there and the gear set that's in it. Every transmission, the pump set that's in it. I guarantee that metal's been cryoed. And if someone can move a penny out of a part, it's automotive. But they don't. Everything gets cryoed. Now, why is that? Well, toughness, realignment, and you can see in our scope realignment of materials. So let's say the automotive people don't know what they're doing. Let's say they're all dummies, okay? But what we did in order to prove it to ourselves was the toughness of the tools, how many would break, fasteners, and so on. So we took a piece of D2, 2 pieces of D2. We took a rod, cut it, machine them up to within, as best we could, exactly the same dimensions. One went to cryo, one did not. Then we put on a wire EDM, cut off a wafer off of both of them. Wafer's 30,000 thick. So I got a 30,000 thick wafer, 4 inches diameter. And you go, what's the difference? I'll tell you what the difference was. The one that was not cryoed was a Pringle potato chip. It was over 100 thousandths out in warp. Because when it came off, it went, the one that cryoed, flat. Okay. What's the difference? Stress. Nothing else. Well, me as a shooter, do I care about the stress that's in the barrel? Yeah. Do I care about the alignment of the molecular structure? Is a better alignment for what we're doing to it? Yes. So therefore, we do a cryo. But for us, the cryo guys only do it 1 day a week. And if you miss that cycle, you're 2 weeks down. So we start there, plus shipment and so on. Then we always want to, we to your point of where's the cost at, 98% of the barrels we've done, each one's been a one-off. Each one. So each setup is unique unto itself. Each one's a tool in itself because they're, to date, you know, and that's why we're starting to really go toward the gas gun side. You know, the ELR guys, you know, each one has their own variety. What diameter, what length, what bore, and everyone's 100% set up for everything we do.
Oh boy.
And you know what that would cost on your CNC if every one was a setup?
Yeah, no, I don't want to even think about it. Especially with all the machining you guys do to that thing.
Yeah,
oh my goodness.
It's a bit.
You guys drill the length, is it the
Length.
the length of the barrel on the perimeter?
We do it, yep, to a certain depths.
And you were saying that because it has holes in the perimeter,
Yep.
and you're saying as you shoot, it draws air.
Right.
And that helps with the cooling.
On the backside, so I got a core moving down the barrel. On the backside, you'll see a series of holes. Okay, and even those holes, if you look at them, they're kind of staggered. Why are they staggered? Frequency, not to allow a cadence to take place in the same feature. But when the bullet starts down the bore, there's a column of air that sits in front of it, 1 atmosphere. But I'm accelerating that 1 atmosphere, and I'm compressing it to 3,000 feet a second. And as that goes down the bore and it passes through your brake or the end of the barrel, there's a low pressure zone. And that low pressure zone will now start drawing air through those pits in the back, on those tubes in the backside that have been opened up, and will draw air right through it. In fact, there's enough velocity involved that there's been more than one time that we'll get done shooting, we'll find 8 piles of sand stuck to the back of the brake. In fact, Mark and Sam down in the Australia group, we sent him a 33 XC barrel they built. He noted that, and we didn't tell him that any of this about. He said, you know, the oddball thing happened was there was 8 piles of sand at the back of our brake. That's because of the velocity. And there's brake designs where we can actually move that velocity upwards of 25 meters a second through the barrel. So every shot that is taking place, solution to pollution, dilution. So I'm actually replacing the air within the barrel with a cool charge. So it'll move in once, then the brake or muzzle goes over pressure, and air will move back through it again. So twice within a round, we move air through a much larger surface area. The barrels you're shooting today compared to a standard barrel have about 450% more surface area. And when you're talking about hundreds of percents, you can measure that. 10% like a standard flute. That's hard to get out of the noise. But those are meant to move air efficiently through the system.
Makes sense. So 4 months.
Yep.
To 6 months.
Yep.
Plus a year to get a barrel.
Well,
we're looking at a year and a half.
I think that's part of it.
Can we speed that up a little bit?
Yes, we can. And because what we're doing is, as we've become more accepted, and actually where our greatest acceptance has been is on the gas guns.
Okay.
Because what happens there is people who shoot gas guns at any level, they know what heat means. That's it. That's probably the first thing in their head is heat. So it occurs at a different level than, let's say, a typical bolt gun person. The bolt gun guys, they'll talk about heat, but they're not going to go shoot 40 rounds in a row. Gas gun guy, in a blink, that's 40 rounds.
Well, that's
right?
what we did today. Today with that 6.5 Creed, we just, especially when you said shoot as fast as you can.
Right. You start going through rounds. And therefore, by doing that, it allows us to standardize our barrels and our process. All of a sudden, a setup isn't every one. It's now 10 in a row.
Right.
All of a sudden, those values come down. And it also allows us to go buy blanks. So we can put blanks in stock because we know we're going to sell this. We buy the wrong blank at ELR level. You know how long the blank will sit there? Or if it's the wrong bore, the wrong twist, the wrong versus if I'm going to buy a 6.5 barrel, I can go say, I'm going to go get a 7.5 twist. Basically, everybody's going to say, find a 7.5 twist. I bring a blank in that's 26 inches long. That probably just covered 95% of all 6.5s that we made. Or if I did 6 millimeter, I'll get a 7 twist, get it 26 inches long. They'll all be 1.5 inches in diameter, every single one. And then all of a sudden, the volume allows us to bring prices down and that lead time.
Now, what about, you say you put on a gas gun. What about it? Because they're diameter-wise, they're bigger. Mm-hmm. How do you deal with the gas tube?
Okay, so one, we have to be careful who we use for upper and specifically the handguard.
Yeah, so there's some limitations there.
There can be, right. It's amazing how many more people are making a little bit larger handguard that will take the 1.5 inch barrels. Mm-hmm. We will also make our own gas block. We have to. And because we have to we have to time the extension and this alignment pin, but we have to time our gas event. And because it has to be lined to one of the I-beam areas. And we put a pill in, and the pills are designed to be such that within reason, the pill's already gone a long ways for your optimum tune on the gun versus you chasing it. And it can be replaced. You can replace that gas event with a smaller or larger pill, if you want to say that. And then we run our gas blocks, we build them to the barrels. And back to your same point, to date, I think every gas gun we've done, we've had to make a unique gas block because they want a different diameter. So back to the CNC. This is a different program. Oh, it's a different size, and so on. Versus if we all run 1.5 inch tubes, well, then all the gas blocks are 1.5 inch. They go in the same place. They get the same components. Everything drops faster.
Right. Makes sense.
We didn't have you check today, but I should have had you touch the gas blocks. They're colder in the barrel.
What?
Yeah.
That makes zero sense.
It makes zero sense because usually gas blocks are scalding. Yeah. Actually, last year we were shooting at shot. We did an evening shoot, and everything we shot was night vision, and we went from like 8 o'clock to 3 o'clock in the morning, right? And we had a couple gas guns out there, and we had brought a 6.5 Creedmoor that we had just barely got run, couldn't get a scope on it. But they're shooting it, and the owner of this company takes the gas block, puts it against his cheek. He says, "Where have you ever heard of this?" That's the point.
Yeah.
It is the point, is to how can I run it cold? And, in that night, that was an interesting night because we had two 300 numbers out there. We had the one you shot today, and we had a 300, an MRAD that we had just completed. Now, we modify the MRAD to run the way we have it run. There's no maze about it. But that gun was 65, 70 shots in, and it was 59 degrees outside. And we measured the barrel. It was 80. Okay. The chamber was sitting at 72. The suppressor was 212.
Wow.
Okay. And the consistency, at that point, and I'm not shooting, we have Chase Stroud is shooting, and we're having different guys step down and shoot. And they jumped out to 2,100 meters on the gun that's just had 60 rounds through it. And they went first round hits. Night vision, 2,100 meters on a gun that just ran a string of 60 rounds. That's back to the ES and the SD. Is it consistent? Is it predictable? I didn't have to make a change. I didn't have to make an offset. I'm still shooting the same numbers I did when I pulled the gun out.
Yeah. That's impressive. So, chamber after you do all the work
Absolutely.
to it?
Yes.
What about, let's say I order a 30-inch barrel and now I want a 28. Can it be cut down?
Oh, yes. Absolutely.
I'm talking about, can I cut it down after you've done all the machining?
Yes. If you can do muzzle work, we have a specific configuration we give to the gunsmith because our goal is to make it breathe.
Right.
I also have configurations on my muzzle work mainly for stress and how load of stress is applied to the threads and how the barrel is moving around that stress point. Okay. A lot of gunsmiths not might agree with it. That's their call.
Yeah.
But you can chop off the end and rethread it, not a problem. And in fact,
what about the other end?
Yes, you can.
Perfect. That was my next question.
You see, when we build the barrel, we have a series of vents. The dimples you see are one vibration event, but also in the interior of the barrel, how it's being stepped up. So we have a chamber, we have a throat. Depending on the caliber, there's 1.5 to 2 inches of solid material that's not drilled. And for two reasons. One, we want that to be the most stable, strongest part of the barrel. You think about it, from an explosion standpoint, an 1.5-inch solid barrel at the chamber or at the throat makes it probably pretty strong.
Oh, yeah.
But what takes place then is that you can now sink around in a few times before you hit that 2-inch number. And if you tell me up front that I'm going to want to redo this, I'm going to want to set it back 500 thousandths every time, 4 times, well, fine. I'll build you that depth into place so you can move it.
Well, I usually don't set barrels back, but if I was going to test this, then that would be another test.
It'd be another test.
Right?
Yep.
It's like, all right, well, let's say this barrel went from shooting whatever, half MOA, quarter MOA, whatever it may be. And it did, obviously, I'm going to shoot as many rounds as possible. And it's like, okay, it is no longer doing that. Let's see if I can get it back by chopping it back an inch or whatever. And, that'll, and if so, two things will happen. Either it will or it won't. If it does, how long does it last before it goes and it's done, right? Because, again, $1,200 or so added to the cost of the barrel. I'm going to try to get as much out of it as possible.
You betcha.
And I like to know how much by setting it back. Because the reason I don't set back barrels is because it's not worth it. It's, you're paying a gunsmith $300 to set back a barrel. That's $300. So
right.
Just buy another barrel and just pay them to rechamber a new one.
And to that point, I think you noted earlier, the grill in the room.
Right.
What's the cost?
Right.
And to your point, all those are true statements. No maybes. Our next generation barrels, we have two other designs. One is specifically to dress cost. Will it be as capable as this one? No, 70 or 80%. The average guy might go, that's plenty. I'm good. I'm happy. Here's my cost. We're also in materials that we had a Norma here that I expect 5,000 to 7,000 round life out of.
Wow.
For about
now you're throwing
more.
out some big numbers. I want you to know that.
That's fine.
I mean, you know what I mean.
I know what the test on the material is because I have the data.
All right.
Therefore,
$1,200 added is a huge expense.
it's a huge expense.
But if you're saying, well, you're looking at $400 4 or 5,000 round barrel life versus, I mean, you're doubling right now. You're like, okay, well, now it's still not there, right? Because the barrels are 300, 350,
Right.
whatever. But by the time you get it chambered, so now you're looking at about $700 or $800. Let's just say high end, $800. Okay. Well, now you're almost there.
Right.
Right. Now, that's just we're just addressing the cost right now. But now if you get the benefits of no flyers and just the consistency of you can shoot just about any factory ammo through it, it's going to do well. So now all the benefits is for another $400. Now we're down to $400. That's assuming you get twice the barrel life. But if you get more than twice the barrel life, so you would have to get 1.5 times more barrel life, and now you're there. It's a free process if you can get 1.5 times the barrel life, right? Because $1,200. Now you, money wise, you broke even, and now you get all the benefits.
You start getting benefits.
Additionally, you don't have to load. You don't have to go find another load. You don't have to read through this barrel, any of that good stuff that we have to do. So, I mean, I can see the benefits. I can see the why somebody would do this. What is the reason people do it mainly? I mean, $1,200 is a lot of money.
The people who shoot our barrels, and we have people who've bought 9 and 10 barrels, and they all say the same thing because they just plain shoot. He says, "I get the barrel, I know it's going to shoot." He's done, and that means something to them.
For me, sorry to interrupt, but if I could have the same 2 rifles, because I always have a main and a backup, and we travel all over the world essentially, to some degree. And if you have 2 different rifles with 2 different barrels, and you have to load 600 rounds for a competition. Well, now you have a backup that shoots a different load. Guess what? Now you just have to load 1,200 rounds. Right. Not only do you have to load the 1,200 rounds, you have to pay to get them there. Right. And it just gets expensive.
Or within reason, a backup rifle with that barrel will just shoot it. That's what's going to happen.
Yeah, that's what I mean.
That's
very interesting. Well, I'm doing I haven't announced it, but I'm going to announce it right now.
Okay.
I'm doing a dedicated Blackjack Challenge rifle. I'm going to build a rifle specifically to shoot my Blackjack Challenge. The goal is 12 impacts.
Okay. 0
misses. So maybe this is a great place to test your barrels and because obviously I'm going to be shooting 12 rounds as fast as possible. So heat is going to be an issue.
Becomes an issue.
And of course, the last target is the 2-inch target. So I need to shoot 5 rounds, and then of course I'll have 7 at the end. And I need the barrel to stay as consistent as possible. So that's why I'm thinking I might just have to give this a try.
The consistency, your predicted consistency will be higher. Because in the end, physics works for us and math is working for us. And I know you said earlier that we talked about that you can build a house and some architect will say, put this beam up, and you're going, how the heck are you going to get that beam up there? It ain't going to work. And they're going, yes, it will work. No, it won't work. Well, that's because the guy never did it.
Right.
He's never put it up there.
Right.
But the difference is for us is the physics works, the math works. And we're not talking about small percentages. We're talking giant percentages. Weight for weight, 50%, 56% stiffer, twice as stiff. Well, that adds up. Surface area adds up, and we see it then we go downrange and what people shoot. So the ability to put in something into your hands that's predictable has a worth. And today when I walked out here with you and I brought those 168 grain rounds, I never shot that bullet before. It wasn't one of my tests. This was, I found some Sierra 168 TMKs on. I don't know when I bought them. I don't know how long ago. And I put them in and I looked at what my old data was. And last time I shot this test was 2021. And it said 81 grains. And And I couldn't remember if that 81 grains was the hot load, medium load, or low load. So I took 5 pieces of brass, stuck them together. I didn't weigh the brass, didn't prepare it. Put the rounds in, checked them for concentricity. They all measured within 2. I said, okay, this is the test. So yeah, when you said 500 yards, I went a little bit. And because I wasn't sure how well the bullet would continue flying past 100.
Right.
So
now what about barrel tuners? Like, I know you're killing the vibrations, you're killing I keep saying killing. You talk about you're redirecting.
I'm redirecting.
Do you think a barrel tuner will have any effect on your barrel?
Given the right tuner, yes.
Okay.
It has to. It has to. See, one of the things I started talking about was when I made, and this is my past, when I made the stack. The vibration didn't matter. If I changed that center section, what they call a booster, they have gain boosters and reducers. Now, what do you think that those simple terms mean? It means
more or less.
More or less. And it means how much the tool's going to vibrate.
Right.
More or less.
Right.
Well, if I can change that movement, double it, or cut in half, or whatever number I want, just by changing the shape of that booster, well, what do you think's happening in the barrel? Same thing. It's real world. So applying how that's applied to the tuner is exactly the same way. Are we going to make it perfect? No. Are we going to probably get close to perfect? Maybe. But to your point, how do I make a 0.7 gun a 0.5 gun? How do I make a 0.5 gun a 0.3 gun? And what if the barrel, if 90% are barrels, 95 or 0.5 or less, and you finally choose a bullet that you're happy with, that's consistent, and you go, okay, I'm at 0.3, I want 0.2. Guess what? The tuner's going to work. It has to work. Back to that physics, it's going to raise his ugly head. The thing is, we're using it to our advantage, not an ugly head. It's a pretty head. We're going out with the pretty girl, not the not the ugly girl.
Maybe we shouldn't go there. All right, man. I'm interested. You make a lot of other stuff. We didn't even get into the Charlies, and I know Chase has brought his out here, and it's simply a periscope, right?
It is a periscope, yes. The Charlies are periscope. We make 2 versions. One's a static. Now, when I say static, the end user can move it. They just need a tape measure. And at some distance, they can move it along a tape and reset it. And it's 3 bolts. It's pretty gorilla proof. It would have to be really abusive. We've only ever had 2 come back that were broken. and they were broken pretty good. But they're easy to reset. Now, the other one, we have a fully settable, that's adjustable. You go click, 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 click.
Right.
I can go from negative mil to 300 mil.
And
so it's a big number.
The way they work is they simply redirect
what you're looking at.
What you're looking at.
Yep. In some ways it's simple. In some ways there's a complexity to it.
So at some point, right? Because opposite to what people believe, you're aiming the scope down.
Yep.
Right. So everybody, when you dial up, you're aiming the scope down.
Yep.
Which, let's say you're here, you dial up, it points the scope down.
So I got to go like this.
So then to get it back on plane, you do this, which brings the barrel up, which makes you shoot higher.
Yep.
Right. So at some point, you get extreme enough,
you'll see the barrel.
You will see the barrel.
At that point, you have delta.
But you have an answer for that as well.
Yeah, a delta. It looks around the barrel. And we also have a smaller version that is meant specifically for guys with suppressors. Since they're not LR guys, we don't have to have as big a unit. It is meant to look around suppressor heat, the rise and the mirage into your field of view.
Okay. So ELR.
Yep. Then the funny thing is 22 guys. I don't think they've found those units. But from a 22 standpoint, especially when I can dial, I can go click, click. And the advantage of dialing is I never have a gap. I can go to 300 mils and I see my shots all the way out. There's no we're kind of in the middle of everything. Can you see where it went? I can actually walk it all the way out. And now the next one up would be the Bravo. And that's a simple wedge that sits in front of the scope. But the main difference between the pair, one is a look through, the other one's a reflected image, but the Charlie always raises the image higher. So its effective mirage is always less than the other material, because the other ones, no matter what, is putting you closer and immediately closer to the barrel. Okay. Now, in the case of the Bravo, they can be stacked, and we have an advantage is we can make 0 mil to 90 mil, anything in between. Okay, so we can make it specific to your needs and what application. There's scope mounts versions and there's rail mount versions on both cases, and they're both Legos. Mm-hmm. So if I have a scope adapter, I can put a Bravo on, or I can put a Charlie on. Doesn't matter. If I want to take it off and put a rail base on it, we put a rail base on it. Okay. Now we run our rails a little different than other people do. In fact, the Norma was an example of that. It was the other Norma. We run a continuous rail on the surfaces, but the front end is fully floated. It's not bound. So that way, no matter what gun it is, it's going to move. We want that rail to move on its own, be able to have enough flexibility and movement in it that you don't start shearing mounts on the backside.
I see.
Then the Alpha. That one is meant for mid-range, rapid engagement, and we set that up around point-blank range conditions. So if I have a 50-meter zero, you tell me your gun has a 14.5-inch gun and 223, and you give me a velocity, and you say I'm going to shoot a 40-inch target, we will give you a unit that will take that 50-yard zero and allow you to engage the 40-inch target where the bullet will not rise above the 20 inches and drops down the 20 inches. So all of a sudden I go from 50-meter zero to a full out to 400 meters, put the dot on the guy, because you're shooting kill zone. Mm-hmm. It's a different methodology, and I think a lot of times hunters are aware of that because they know what a kill zone is. They're deer, they're hogs, whatever, but there's not usually something that says, how do you engage it quickly? How do you apply it rapidly? Or versus having your own, and you can have a unique zero to do it. The advantage we have is that we can give you one, we can give you the other, you can have both in place, and it doesn't care what the optics is. It does not care. It doesn't care if it's an ACOG, dot, holographic, LPBO. It's going to pop you that number, and all of a sudden you have a known kill zone that you're engaging target with. So,
very nice.
A bit of a range.
John, thank you.
Oh,
it's a lot. That's a lot to take in right there, especially the barrel technology. We were, like I said, we went out and shot them today. They were, it was quite interesting. Everything about it. Again, the tests were with the different grain bullets going almost 200 feet per second different for them to, at 500 yards, print one MOA group in 15 or so mile per hour winds was quite impressive. Good. And the recoil, everything, the cooling. I mean, the thing never got hot. It was, 12 degrees, I think, is the most we saw, and we were rapid firing on that AR-15 or AR-10, literally as fast as we could.
You were starting to have fun.
It was fun. I mean, yes. Who hasn't done a mag dump and had a smile on their face, especially when we hit at 500 yards every time. Yep. I mean, we there was no misses. It was like 100% impact rate as fast as I could squeeze the trigger at 500 yards. Anyway, no barrel heat. It was impressive. So, good job. Continue doing what you're doing, and you're welcome back anytime. Bring plenty of ammo, because next time we're gonna be ready.
I will do so. We'll now you know something more about it. We can be both more targeted and have more fun.
Exactly. I didn't know what to think, and even when we left, you said, "Well, we're gonna go shoot. Just shoot as many rounds as you want." And I grabbed some extra ammo because I didn't know how much fun we're gonna have. But we ran out of time. We had to come and do the podcast. But next time I will be ready.
Okay. Sounds good.
All right, John.
Thank you, Eric. Thank you for having me come down here. Let me come down.
Thank you.